Okay, today we're going to focus on domain and range of functions. Okay, so functions f of x equals stuff, or h of x equals stuff. The things we just looked at were functions. Domain is any value that can be used to replace x without the function being undefined. All right. So domain's all about restriction. All right. When we look at functions such as a polynomial function, do we know what a polynomial function is? X to the third plus 7x squared minus 2x plus 1. X is raised to powers. Add and subtract the terms. That's a polynomial function. It could be x squared, it could be x to the first, whatever. It's just got x as being raised to powers, being added and subtracted. Polynomial functions have a domain of the set of all real numbers. There are no restrictions. I can square any number in the world, I can multiply any number in the world, I can add and subtract any number in the world. There's no restriction whatsoever with that. Square root functions, such as the square root of x. Any restrictions on that? Anything out there we're not allowed to take the square root of legally? Square root of 4 equals 2, square root of 3 equals some decimal, but it equals something, right? Square root of 0 is 0. Anybody think a square root is something that's not allowed to happen? Some number times itself makes a number. That's what goes underneath the square root symbol. I'll give you some examples. The square root of 4 equals 2, because 2 times 2 equals 4, right?
Square root of pi, right? That's
Square root of pi is equal to some number between 1 and 2, 1 point something. But it equals something, right? One time, that number times itself makes pi.
Yeah.
Okay. When you multiply a number by itself, what kind of sign do you get on your answer every time? 3 times 3 is positive 9, negative 6 times negative 6 is positive 36. 6.
Positive?
Positive, every time, right? So, if I have the square root of negative 9 equals what?
Negative 3 and 3?
Well, let's try negative 3. Negative 3 times negative 3 makes positive 9. That's not right. Positive 3. 3 times 3 makes positive 9. Doesn't work. Can't take it square root of a negative number, right? It's not possible. 3 times negative 3, but that's not what square root's asking us for. It wants a number times itself, not a number times its opposite. So, for square root of a function or a square root function in general, whatever the radicand is, everybody okay with the word radicand? Have I used that word before? The radicand is the contents of the square root symbol. Square root is something. Whatever the something is. The rule for domain is that the something has to be greater than or equal to 0. And then you solve that. For example, square root of x minus 3. If I'm doing that problem, I know x minus 3 must be greater than or equal to 0, so that means x must be greater than or equal to 3. Pick a number that fits that description. Let's try 3, for example. 3 minus 3 is 0, square root of 0 exists. Bigger than 3, 4. 4 minus 3 is 1, square root of 1 is 1, that exists. Pick a number that fails, something not greater than or equal to 3, 0. 0 minus 3 is negative 3, square root of negative 3 is undefined. Alright, so whatever the inside of the radical is, set it greater than a 0, greater than or equal to 0, that will be the domain. Alright? The other thing we're going to run into in this class is division. So, divided by something. So, whatever the top is, divided by something. Okay. What are we not allowed to divide by?
0.
Can't divide by 0. Alright, so if I got x on the bottom of an expression and I'm trying to find domain, I know whatever the bottom is, in this case the something on the bottom, it cannot equal 0, or else we're dividing by 0. So any value of x that creates division by 0 is no good. For example, if I have 1 over x minus 2, what makes the bottom equal 0? 2. So the domain of this would be x is not allowed to equal 2. That's all domain is. Of all the numbers in the world, use anything you want to, just don't use 2. Okay? Of all the numbers in the world, use any one of them. Polynomial functions, all real numbers. Square root symbol, whatever makes the radical not negative. Square root of a negative number. So, as long as it fits that description. Alright, domain's pretty easy in the whole scheme of things. There's rules. You apply the rule, you get your answer. And we'll do some specific problems. You'll see each type of these things show up. Range is a little bit trickier because range is what comes out of a function. And a lot of times, once you've established the domain of one of these things, you can graph it and see the y-coordinates where they're going. And that tells you the range. So all possible outcomes, the outcomes are the height of the graph. So if you have a graph that does something like this, the outcome is the y-coordinate, right? So the input is the x-coordinate, and obviously, seeing as it's going all the way both directions, x can be anything. But y is stopping at 0, not going below 0, right? So the range of this would be everything greater than or equal to 0. Right? So to do range, a lot of times you have to graph them. If you were to graph a straight line, it goes all the way down, all the way up, all real numbers is the range. Okay, so when you're worried about range, you're asking yourself, how far down does it go, how far up does it go? What's the bottom, what's the top? That's how you find range. So graphing is usually required for range. Because of that, all we've learned how to graph so far is lines, right? So expect if it's a range question right now, they're either going to graph it for you, or they're going to be graphing a line. All right, and on that note, find the domain and range of the function f, where f of x equals 2x, which by the way is the equation of a line. F of x equals 2x. So let's take a look at this. F of x equals 2 over 1x plus 0. I created that slope-intercept form we've been becoming familiar with. I made my slope a fraction because slope's better as a fraction than a whole number. And I made sure the plus 0 is there because that's my y-intercept. And f of x is just a fancy way of saying y. You really get down to the whole bare bones of this. That's all f of x is just y. So I've got my x-axis, my y-axis like normal. I've got a y-intercept of 0, which means that the y-axis is intersected at the origin. And a slope of 2 over 1, which tells me every time I go up 2, I go right 1. Up 2, right 1, up 2, right 1. I keep doing that again and again and again until I'm tired of doing it. And then I just connect those dots with a nice straight line, because we always connect dots when we're graphing lines. And the graph, you can see very clearly, goes like that. Domain is everything I can put in, range is everything that comes out. So think of domain as an input and range as an output, and we're trying to identify this stuff. And of course this is math, and it's very important that we write in very specific notation when we do this. So here's what it looks like. Domain equals, you can use a brace or a set bracket, take your pick, but it's going to be a set. Domain's all about x, the input. So here's how you write this. Domain equals x such that, which is a vertical line, x is an element of the set of real numbers. And then you finish off your set bracket. Okay? So this is the whole components here. This is called set builder notation. That's got an actual name. They call it set builder notation. Very important. It's written just like this. A set symbol, either a brace or a bracket. If you don't like the braces, the square brackets are fine. Doesn't matter to me, one or the other. But use some sort of a set notation. Don't use a parentheses, bracket or brace. You define the variable of domain, which is x, and you tell me any restrictions x has. X is an element of the set of real numbers. Okay? X must be greater than 17, whatever. If there's any kind of rule, restriction, whatever, tell me what it is. All right? Range, what's the y variable in this case? In the original problem? I called it y, right? Well, what is it really? It's really f of x, right? So range is all about f of x. And the rule in f of x is, if you look, how far down does it go? All the way, right? How far up does it go? All the way. So it's going all the way down, all the way up. Every single number is hit, so all real numbers for that also. F of x is an element of the set of real numbers. That's how you write domain and range out. Okay? using good mathematical symbolism, that's how you write it. And when they ask for domain and range, that's the type of answer you should get. Domain equals everything about x such that, and then tell me about x. Range, all about f of x such that, tell me about f of x. When you're asked for domain and range, that's how you do it. There should be a graph accompanying it because, again, at this point you can't do range without looking at a graph.